Start. Start. Move.
So, in this video, I, Ashmita Chakraborty, is going to present on the topic vector processor along with my team members Soham Das, Vasundhara Sengupta, Shobhik Dotto, and Sneha Chatterjee. Firstly, we would like to express our gratitude to our teacher, Mrs. Shudipta Roy ma'am, for providing us support and guidance whenever we needed it. Secondly, we would like to thank our college for providing us with a marvelous opportunity to learn and present this topic. This project helped us to gain, explore, and conduct a lot of research about this topic. So, firstly, we know elements of the vectors are ordered properly as to have successive addressing formats of the memory. This is the reason why we have mentioned that it implements the data sequentially. So the first thing that comes to our mind is what is vector processor? A vector processor basically a central processing unit that has the ability to execute the complete vector unit in a single instruction. More specifically, we can say it is a complete unit of hardware resources that executes a sequential set of similar data items in the memory using a single instruction. The next is the architecture and working of the vector processor, which will be explained by Shobik Dutta.
Thank you, Ashmita. Architecture and working. The figure represents the typical diagram showing vector processing by a vector computer. The functional units of a vector computer are as follows. IPU instruction processing unit, vector register, scalar processor, vector instruction, controller vector, access controller, vector processor. Moving to the next slide, operation of vector processor. As it has several functional pipes, thus it can execute the instruction over the operands. We know that both data and instruction are present in the memory at the desired memory location. So the instruction processing unit IPU fetch the instruction from the memory. Once the instruction is fetched, then IPU determines whether the fetch instruction is scalar or vector in nature. If it is scalar in nature, then the instruction is transferred to the scalar register and then further scalar processing is performed. And the next slide is elaborated Soham.
Classification of vector processor. The classification of vector processors relies on the ability of vector formation as well as the presence of vector instruction for processing. Now, register to register architecture. This architecture is highly used in vector computers, as in this architecture, the fetching of the operand or previous results indirectly takes place through the main memory by the use of registers. The several vector pipelines present in the vector computer help retrieve the data from the registers and store the results in the desired register. These vector registers are user instruction programmable. Now the next slide will be discussed by Sneha.
Thank you, Shoham. So now let me tell you about memory to memory architecture. Here in memory to memory architecture, the operands or the results are directly fetched from the memory despite using registers. However, it is to be noted here that the address of the desired data to be accessed must be present in the vector instruction. The architecture enables the fetching of data of size 512 bits from memory to pipeline. However, due to high memory access line, the pipelines of the vector computer requires higher startup time, as higher time is required to initiate the vector instruction. Some examples of supercomputers that possess memory to memory architecture are Cyber 205 and CDC, etc. Moving on to the next slide. The advantages of vector processor. Vector processor uses vector instructions by which code density of the instruction can be improved. The A sequential arrangement of data helps to handle the data by the hardware in a better way. It offers a reduction in instruction bandwidth. Let me conclude this presentation. From the above discussion, we can conclude that register to register architecture is better than memory to memory architecture because it offers a reduction in vector access time. So lastly, there is some references of the links which we use to create this presentation. Now, thank you for your patience hearing. Hope you all have a nice day.